When you're making a paper-based level layout for a 3D game, there's a lot of more things to consider than when you're making one for a 2D game. You have to think about things like sight lines, and also elevation changes in the terrain of the level, and even how the camera is going to move in the game. And it might seem pretty tricky to make a 3D level layout, but there are some simple conventions we can use to make it easier. One of the most popular methods is to create a top-down representation of the 3D level. This is basically like a bird's eye view, or like a level map. It is from the perspective of looking straight down at the level from above. And so we can just represent things like walls and gaps and enemies from a top-down view. And there's a couple of tricks we can use to represent elevation this way. We'll get into those later. Another technique that you can use is to make what I call an imaginary screenshot. This is taking one point of view, as though you were playing as the player in the actual game, and just capturing what you would see from that perspective, that one perspective in the level. And this basically works really well for scene compositions, almost like you're composing a shot for a film, and it's good for getting an idea of what the level should look like from one specific spot. If you want there to be a grand vista where the player sees everything from one specific perspective, that's a great time to use that imaginary screenshot. It also works really well for small sections of levels, like a puzzle, where things are only moving on two axes. So in one example, say it's a climbing challenge in an Uncharted-style adventure game. Since you're only moving up and down and left to right along one side of a wall, you don't actually need to consider moving backwards or forwards like you would in other movement through 3D space. So it's really easy to represent those as a 2D drawing or like a mock screenshot just looking at it from one perspective. I'll go over both techniques in this video. First, let's start with making a top-down level layout for a 3D game. So one other thing I'm going to put here is the enemies in this game, because it's a top-down game. Let's say that they have a field of vision. So what that means is they can see the player in a certain range like that. Wow, that's a really bad triangle, but you get the idea. And what that means is that if I'm behind an enemy, he may not see me. So let's keep this simple and say that an enemy has a triangle of vision that is like this size. So it extends about 3 squares and about 3 squares. So that's a pretty big vision cone, but it doesn't go very far. And then I'm just going to represent this in pink. If I were drawing this on actual paper, I would like lightly shade this to show where the vision cone is. And so we'll keep that in mind, because this is going to be really important for defining what the enemy encounters are going to look like and play like. So now let's define our gameplay area here. Let's just do this really easy like this. So over on the right here is going to be my prototype. And let's start drawing. So in this case, where before we were drawing the lines as platforms and we were keeping in mind that there's gravity in this game, so we're kind of just jumping and moving along left to right. In this game, since it's top-down, our platforms are actually going to be walls. And these are things that we have to keep in mind. They will block line of sight. So in this case, it's sometimes a little bit trickier to decide where to start and how we're going to build the structure of this space. But we got to start somewhere. So let's just say we enter from the bottom, and I'm just going to make some walls here. So this is like my entryway. And I'm still going to draw in units of 1. And I'm kind of just drawing out what might be some cool shapes for rooms. So if this is my entrance, it's important to put the player there, so we know that that's where they come in. Player. And then let's go back to drawing kind of the outline for this building. So what do we want the player to do? We want them to walk in here and maybe see some enemies over here. And we want them to have places that they can block line of sight so that the enemies won't see them and they're not always getting in combat. So I'm actually going to put we can call this a pillar or like some other kind of wall object that's blocking line of sight here. And maybe we'll put one here too. And let's say that there's a wall. Well, let's put it right here. And maybe this is a hallway over here with a big room at the end. Like that. And so there's this entryway here. And in a top-down layout like this, where you have things that are not rooms, but walls, but they're more than one line thick, sometimes it's a little tricky to understand that that is like not a place that the player can go. So I'm going to dye these gray like that. And I'll add this to my key. Let's just call this obstacle. And I'll get this gray color and whoops, like that. And once again, if I was drawing this on real paper, I would just lightly shade that to show it's that color. So now I have kind of this area where I'm walking around, but it's a little wide open in this region, so maybe let's kind of start to block this off. We'll put another wall here, so this is kind of like an alcove, and make this kind of a narrower corridor. Let's do another big room like this. And maybe we'll have like a little hallway over here, or like a zigzaggy kind of situation. And then finally, one more room. And we'll put another little room over here. So this is kind of a funky level shape. And also something, since this is getting a little bit hard to kind of keep track of, like where is the actual playable level, I'm just going to take this gray obstacle color and color the whole outside. So now this is much more clear of like where I can actually play. So now I've done this again where I created this whole kind of outline of the level space. Let's go back through and add coins. Or actually, instead of adding coins first this time, I'm going to add enemies, because they are going to really change how this level plays. So if I have an enemy, we'll put him right here. And we'll say that he starts facing this way, which is kind of hard to represent with this squares. But we'll do it like this. And make sure I can shade in his vision cone. So what this means is that if I walk in at the start of the level, he's facing this way. He's not looking at me, and so he's not going to run towards me. And that's important because I can kind of have almost a stealthy element, and I know that I'm not immediately going to be in combat if I walk over here. And another thing that's important to keep in mind here, is if they have kind of a patrol. So maybe let's say that he walks down here and back up here. So he turns and then he goes over here and he just walks back and forth along that path. So that means that he would theoretically be turning around at some point to look over this direction, and that kind of means I have to time my movements around here. So let's put another enemy. Let's put him like, maybe I'll do one that just walks back and forth. Between here. And we'll set his vision like this. So notice here that because there's this wall here, and there's also a wall here, although it doesn't block as much. But if he is over here, he can't see you if you're right here. Of course, his cone doesn't go that long in the first place, but if you're behind this, he's not going to be able to see you. And let's say one more important thing in this game. Let's say I have a range as the player. I have like a ranged little magic bolt that I can shoot at enemies to get rid of them. And that has a range as well. So what that would mean is if I'm behind this, not only can he not see me, but I can't shoot him. And that's really important for gameplay in these kinds of games. So let's go ahead and color his vision cone, and let's give him a patrol that just goes back and forth. Like this. And also in top-down games, sometimes we're working with a grid system where it's important to work in units of one, which is why I have done that with all the tiles for this like room structure. Although sometimes in a top-down game it's less important to do that because you usually have free movement. Like you're not limited to just moving this many squares. But it just depends. So keep in mind the type of game you're making. So now we have these two enemies. Let's do maybe one more enemy in this space. And maybe he's a strong enemy. So let's put him right here. And let's say he starts out looking this way, so he can kind of see. Let me do this. So if you're over here, he can kind of see you. So you can fight him in this hallway, or you can move into here. But also, if he's right here and you're standing over here, you can kind of duck out of cover in order to fight him. So you can see there's kind of a lot more complicated considerations that go into making the enemy placements for a game like this where there's sight lines and it's top-down. And this is a lot more close to the process of making a level layout for a 3D game than a 2D one. So let's do another big enemy, kind of same deal. And let's say he starts out looking in this room, this direction. So you can kind of get the drop on him. Okay, it's a lot of enemies. So let's maybe do like one more. Oops, wrong color. One more little enemy over here. And let's make him go like this. Just a short little patrol path. And let's also say that he looks this way. This is kind of his range. Okay. So this is getting more and more complicated on the page, but you can still kind of tell this is his path. He's got this vision cone. And now we've got a whole bunch of enemies. This is looking pretty dangerous. So let's go back and add some incentives to get through all of this. I'm going to put coins in these little alcove rooms to encourage you to explore and move around. Let's do a bunch of coins in here. And I'm going to try to keep the coins out of the main areas where you're fighting the enemies. And that is because, similar to for the platformer game, I don't want you to be thinking about getting coins at the same time as you're trying to fight an enemy. Sometimes that gets kind of hard. But I can put them in corners. Encourage you to kind of sneak around. And I also want to give you a reward for doing difficult things like fighting a hard enemy. So we'll put some coins in here in the corner. And I'll put a couple down here. And let's also put some coins over here. Okay, so that's a lot of money. Maybe we'll put just a couple more. And we still have this room over here, which is kind of like a zigzaggy corridor. And I think I want to put the NPC over here. And I want them to be out of the way of combat. Ideally, in a game like this, you would have a door or something here where once you're out of the main combat area, you're safe. Because you don't want to do combat in the same place where you're trying to talk to an important NPC. That's kind of annoying when you have to do that. So let me put another coin in. Whoop. And let's put, as a reward for getting through this level, where you had to be all stealthy, let's put a bunch of coins in here. And then I will finally put my NPC that you talk to when you beat the level. He got kind of big, but that's okay. Alright, so now we have this top-down layout for our game. And that's, I think, pretty much looking good. I think that's ready to get into a place where I would want to test that. So now that we've drawn this whole 2D top-down layout for this 3D game, there's another question that might come to mind. How do we represent elevation? Like if there's separate floors or some of these platforms are taller than others? Well, there's a couple ways that we can do that. One is to use different shades of a color to represent how high or low they are. If you look at this map, it's a pretty simple just structure of a room or a couple of rooms, but there's stairs. And we can see at the bottom of the stairs, there's a darker gray color, and this represents the basement according to our key. And then there's a medium gray and a lighter gray, and then white. And as we get higher up in value or lightness, that means we're also higher up in elevation in the space. So this is used often in maps for games, and it's pretty good when your spaces aren't that complicated and there's only like one thing in one spot. So what I mean by that is, this is really good if you have walls, and then on top of the wall there's a platform, but there's nothing inside of those walls, like a room underneath the platform. But what if there is? It's kind of hard to represent that this way because we're still looking top down, so you can't see both things at once. Another really common method that kind of takes this but also lets us see those multiple levels of elevation is separating them into different floors. This is really common for games where you are walking through buildings like that with multiple floors. Like if you think of maybe a Resident Evil game, the maps in those games will show you each floor individually. So you might have the basement floor, all on its own, and then showing the arrows to connect it to the ground floor. Now, the ground floor is just one set of stairs over here, so you kind of don't see it. But the ground floor goes up to upper floor 1, which also connects that staircase down to the basement. And you have this main floor here with one set of stairs leading down and one leading up to the upper floor. Now this map is pretty incomplete, but you get the basic idea of separating this into different floors so that you can see everything that's on one floor. And it works really well for things that are overlapping from a top-down perspective, like this section of the upper floor 2 versus this section down here. If there were things there, like pillars or items or enemies, it would be important to know which floor they were on, because those represent different parts of the 3D space. This technique is also common for real-life maps. You might see examples of this if you're looking at, say, a floor plan or a blueprint for some kind of architecture, and basically just gives us a really simple way to represent what is on each vertical layer of the space. It also is kind of similar to real-life maps of terrain. There's something called a topographic map, which represents each level of elevation as it goes up by a couple hundred feet or so, with a different color or with like rings to represent how high up it is. And we can apply this to games if you're making something like a terrain map for an organic area, or you're making a larger world map. So I'll show an example here. Let's say this is just kind of like a land mass, like an island, and this represents some of the playable area of the game. And now we can see there's a darker color, so this is maybe like the base elevation level just above sea level. And then there's some lighter colors with these kind of organic shapes. And that represents stuff that's a little bit higher, like hills. And then over here we have an even lighter color, a bright white, and that's really high elevation. And then in the middle of that, there's a darker color that's darker than sea level. So maybe this is like a volcano or something that goes way deep, a little bit underground. And then we've also got water here. And this kind of gives you an idea of the shapes of the mass as it would be in real life. And the theory here is kind of that light comes from above, so the light shines more, and things that are higher up and look brighter than the things that are lower down that are more in shadow. And if we were to take a more organic map like this, you can take this base form that gives us kind of the shapes and the elevation and layer on a little bit more detail to make it communicate more information to the player. So you could add like some basic representations of what the different climates or kind of landscapes are there. So we have maybe some forests and some grasslands, maybe some snow and pine forest. And then you could even go further and put little icons and names here to represent what each of these areas really is, what the player needs to know about those areas. Now, there's another couple of things that I haven't talked about with representing elevation and 3D game mechanics. So I'm going to pop over to this other one, and this is a fairly complicated layout for a Uncharted style adventure 3D game. I'm going to go back to that example of a game where you have climbing and stuff. You can vault over surfaces that you don't have to climb over, stuff like that. So in this game I've used the elevation shading technique to represent how high up different surfaces are. So you start in this lower area and you can climb up to this main floor, we'll call it, and there's some higher areas that you can vault or climb to, and some really high areas that are kind of like challenges. There's also plenty of walls and some gaps that you could fall into. So in this game, I've used blue lines to represent surfaces that you can vault over. So those are short enough that you don't have to climb, and if you were to try jumping at it, basically you can jump on top of it. Some surfaces that are represented with the black lines, which is just a standard wall, you wouldn't be able to do that. And the idea here is that the walls are too tall, but the vaultable surfaces are just short enough that you can get over them. And then in yellow, I've represented climbable surfaces. So this would be if there's like bricks or something sticking out of the wall, or some pipes or things that you can climb on so that you can get up to higher levels. This is really common in lots of open world games these days, but I'm using Uncharted as kind of a basis for what I'm imagining this climbing system looking like. So this map tells us a lot about the different levels of elevation here. It tells us where things are, but what it doesn't tell us is, what do these climbing challenges actually look like? Because we're looking at this from a top-down perspective, we don't really know where the bricks are sticking out of the wall and what the player's actually going to be looking at. So let's take one chunk of this level. We'll say this little, I don't know what this is, building, little tower or something. And let's focus on that and try doing a imaginary screenshot. So what this is taking this one section of the level and imagining what it would look like if the player were actually playing through the game, and if you're looking at that section from the player's perspective. So if we look at it that way, we have kind of a third-person perspective, which is really common for games like this. And we're looking at this building, and now we can see from this perspective, there's a ledge over here that I can climb on, and then maybe I jump up to this one, climb over here, climb on all these scattered bricks up to this one, and then finally I can get on top of the thing. And this tells us a lot more about the actual layout of that specific climbing challenge. You couldn't represent this in a top-down perspective, but from this perspective you can. So that's a case where it's really useful to make this imaginary screenshot or in-game perspective. Another circumstance where that would be useful is if there was a shot where the player was looking out at a landmark in the distance, or something else like that, where you want to have the objects in the level organized in a specific way to make that shot look really nice. And it's framed well, and it draws the player's attention to that landmark. So now we've discussed all of these techniques that you can use to represent 3D space in a 2D paper-based level layout. So I hope this has been helpful, and I'm excited to see what kind of level designs you will create.